Hello everyone, in this video we are going to discuss the solution for heaters problem. So let's see how we can do this. Alright, so coming to the question, what we need to do is first study our question. So in this question it is said that winter is coming. During the contest your first job is to design a standard heater with a fixed warm radius to warm all the houses. Okay, every house can be warmed as long as the house is in the heater's given range. So what we have been given is that we have some arrays called houses array and heaters array. The houses array, what does this houses array store? The address of the houses on a horizontal line. So let's suppose that this is a road. All right, and on this road there are some houses, and this houses array is storing the house number, house number 2, house number 3, house number 4, house number 9, house number 11, which is present in my houses array. It is containing nothing but house numbers. Alright, now I have heaters array, and heaters array is storing something similar to that. Heater array is contains at which position on the road heater is kept. Okay, heater number. So at one position one heater is kept, and in 8 position one heater is there, and on 5 position there is one heater there. Okay, so this is my road. On this road there are indexes or the number plot numbers, and in these plot numbers there are some houses and there are some heaters and some empty plots. Okay, now what I need to do is I need to design these heaters such that the heat from these heaters are given to all the houses on this horizontal road. Okay, so for example, let's say this house, yeah, house number 2. If I design my heater such that this has a radius of 11, meaning that this heater can give its warmth to the 11 indexes or the 11 plots again uh, on the right side and 11 on the left side. So won't it be very efficient? No, it won't be very efficient, because if I design such kind of heater that radiates heat to such extreme lengths, then this house is going to get burned, right? Because if heat is traveling to such distance, the people living in house 2, house 3 will definitely feel some heat. So we should not design something like this which is radiating a lot of heat. Also, in the question we have been given, we have to design some standard heater with minimum radius. Okay, because one is this reason, one is that the question in which we are doing says so, right? So I need to keep the distance of keep the radius of these heaters as low as possible, but it should be able to cover all the houses. So for example, this heater should be able to heat all these houses. This heater should be able to all the houses. This heater should be able to all the houses. All the houses. Does this question say something like this? No, it doesn't say that. This in this question, it is said that every house can be warmed as long the house is in the heater's warm radius range, meaning that even if there is only one heater present and its range is covering entire house, then it is warm. It doesn't matter if the house is covered with two heaters. For example, if let's say my range is 5, this is going to give warmth till 6th index, and this 5th heater is going to give heat till the 0th index if they was present. Okay, so something like this. And this house is these three houses are covered by the radius of three, these two heaters. But let's say if I don't have this heater, then also I am able to cover the all the houses because my radius was 5. Okay, so it is said that even if there is only one heater, it should be able to heat the houses, all the houses. Okay, so this is what we have been given in the question. Now we need to figure out how we can minimize the radius of these heaters. Okay, the position of the houses and the heaters are fixed, and we need to find the minimum radius. So how we can find it? One thing we can do is we can try to find the distance of heaters from each house, distance of heater on the left side and distance from right side, which is the nearest heater. So for house 2, this is my heater which is closest on the left side, and this is the heater which is closest from the right side. So this distance is 1 and this distance is 3. Likewise, if I need to warm this house, if this heater was not present, only this heater was present, it will be able to warm this house. So this can warm the house, this heater can warm the house if its range is to 1. Alright, now we will see the distance of heater from this house. From left side it is 2, right side it is 2. Now it doesn't matter from where, which heater I am choosing. If their range is 2, it will cover this house number 3. Okay, so 1 should not be my minimum radius, 2 should be my minimum radius. Okay, now I will check with 4. This is my heater which is closest from the left side, this is the heater that is closest from the right side. So this distance is 1 and this distance is 3. This distance can warm the house 4. Okay, but you can see that if I choose the distance 2, then only I will be able to cover this house 3. Okay, so this was all for these 3 houses. Now I have found that at least 2 radius should be present so that all these 3 houses can be warmed with these 2 heaters that are present at position 1 and position 5. Now if we will look at my 9th house, this heater, one heater is present on the left side, but there is no heater present on the right side. So there is no heater present. So if I will try to say some heater is present or not, it will mean that the heater is kept at the distance of infinity. Okay, so we are not going to consider anything that is on the right side for this. Okay, so distance, minimum distance from this house should be 1. Okay, now coming to my last house, the nearest heater is this heater number 8, or the heater that is kept at position 8, and the distance is at least 3, and there is no heater on the right side. So to keep this 11th house warm, what I need is the range of this heater number 8 should be at least 3. If the heater's range is at least 3, then only the 11th house can be warmed. So the minimum radius standard for all heaters should be 3, so that all the houses can be covered when the heaters are present at position 1, 5, 8, and the houses are at 3, 9, 2, 4, and 11 places. Okay, so that's how we are finding the minimum radius. Okay, so let's try to form an approach so that we can solve this question. All right, so have you seen something similar right now? What we are trying to do, we were trying to find the minimum distance of heater with the house, which is the minimum distance from left side and the right side from the heater. Okay, I found one here. For 3 it was 2, for 4 it was 1, for 9 it was 1, for 11 it was 3. I found the minimum distance from which the heater is kept at one house and tried to see which is the farthest house with the maximum distance, and that maximum distance was my minimum radius standard for heater. Okay, so if you look carefully, aren't we trying to find C floor and C from the house numbers, and from where we are trying to find floor and C from the heaters array? Okay, so we are doing something like that. So what we can do is, first of all, we if we are trying to find floor and seal from a array, it is better to have a sorted array. So first thing we are going to do is sort the heaters array. So I have sorted this array. Well, as given in the question, the heaters array is of size m, something like this. Okay, you can see the snippet of the program. Heaters length of the heaters array is something m. So if I'm going to sort a array with size m, average time complexity to do this will be m log m, right? So this is how I'm going to sort my array of heaters. Okay, so now I have understood the question. Now let's move it down and try to okay, thing is wrong here. Well, it doesn't matter now. Okay, so this was my heaters array, this was my houses array. What I did was sort this, and it became 1 5 8. And how much time did it take? M log m. All right, so this much time it take to sort the array. Now what I'm going to do, I'm going to go from one house to other and find the floor. So let's find it. For 3, let's write it floor C, and then we are going to calculate distance from left side and distance from right side. Distance from what? Distance of heater and the house. Heater and distance between the house and the heater. Okay, so for C, my floor will be 1 and seal will be 5. Floor 1, seal 5. If I will calculate my distance from left, it will be 3 minus 1, 2. Okay, for my right side, sorry, this should be R. So distance from the right side will be 5 minus 3, which will be 2. So minimum from this is nothing but minimum distance of house from the heater is 2. Okay, now I'm at the position 9. Need to find floor. I will find 8. And distance from the left will be 9 minus 8 equal 1. Okay, now this is something interesting. Now I don't have any seal here. So what I'm going to do? If this was the case, I will say that I will return minus 1. And distance from the right, I will say it will be infinite. Because there is no possible distance from the right side now. Okay, so minimum distance between 1 and infinite will be 1. Now I'm checking for my house 2. So floor will be 1, seal will be 5. Floor will be 1, seal will be 5. And distance from the left will be 2 minus 1, which is 1. And 5 minus 1 equal 4. Alright. Sorry, 5 minus 2. Okay. So minimum distance between 1 and 3 is 1. And now for 4, my floor will be 1, seal will be 5. 1 and 5. Distance from left will be 4 minus 1, which is 3. And distance from the right will be 5 minus 4 equal 1. 1 is minimum distance. Okay. Now I am at the last house, 11 house. Floor will be 8. Seal will be minus 1 because there is no possible answer here. You remember the houses now? It was like this. Okay, now let me remove this. Something like this. This is my 11th house. There's nothing in here. So I'll say distance from the right will be infinite. Although infinite is not written, but I will just assume that it will be infinite. Okay, so distance from the left should be 11 minus 8, which is 3. So minimum distance is 3. And among these minimum distances, I will try to find the largest distance so that all the heaters, all the houses are warmed. So this is what I'm going to do now. First, I'm going to sort what? My heaters array. This array. Okay. After this, I'm just going to travel all over my house numbers and try to find floor and seal using binary search. Binary search on what? Heaters array and try to find floor and seal, and then just try to calculate distance from left, distance from right, and I will try to find the minimum distance from which the heater is present from that house. Okay, and I will find the minimum distance, and among these minimum distances from all the houses, I will try to find what I'm trying to find, the maximum distance, so that I can create a standard. I can create standard what? Minimum radius standard of all heater, because all heaters are going to have the same radius for heat. Okay, in that radius all the houses will be warmed. All right, now just we are going to code this, and Then we will discuss its time complexity. Okay, so let's see how we can do this. All right, so let's code this and see how we can derive its time complexity. Okay, so first of all, what we were doing was sorting our heaters array. So let's sort this. Arrays dot sort heaters, and then what we were finding, radius. So let's name it answer. Okay, so here it is, and now we need to run a loop for our house numbers. Okay, so int I equals to 0, I less than houses dot length. Okay, it doesn't matter in which order you are trying to find the uh, floor or seal of the houses, for the houses, because we need to find the radius. Okay, we don't need to sort our houses array. So I plus plus. Now what we needed is a floor and a seal. Okay, so there are two things that we need to return from our binary search on our heaters. Okay, so for that we need a pair class. So let's create a pair class. So public static pair, and then that is int floor and int seal, and now constructor, first default constructor fl equal -1. Let's use this pointer as well, this dot fl, this dot cl equal -1. And what this floor and seal is representing, the house on the left is represented by the floor, and the heater, oh sorry, the heater that is closest to the house from the left side is my floor, and the heater which is nearest from the right side is called seal. So now parameter as constructor int fl int cl, and that's it. Let's copy this and instead of -1 now I'll put fl and cl. Okay, so here it is, my pair class is made. Now I can return floor and seal from single function. So pair p will be returned by doing a binary search on my heater. So binary search, and binary search on what array we should do, on heaters array. And what we are trying to find floor or seal of, we are trying to find floor and seal of our houses, or rather I should say house number. So house number is stored as houses I. Okay, now we have received some pair of left side. Now we know which heater is the nearest from left side, right side to a particular house. Now we need to calculate the distance from the left side. So let's name it d1, and it will be calculated as houses I minus, oh not minus, e dot fl floor pair, uh, pair. From my pair class I'm going to use floor, and then d2 equal houses I, and we need to subtract this from what, from our CL. So CL minus. Now think about it. Is it right? Okay. No, it is not right, because there were cases in which we don't have any heater on the right side, or we don't have heater on the left side. So let's take that example. For my 11th house, what was the probability that there is no heater on my right side? Okay, if this is the case, then what's going to happen? We can't have any heater on the right side. So we can just say that if there is a heater present there, it will be at what? Infinite distance. Okay, so let's write a condition that E dot FL equals -1, because I have taken -1 as the default values. See here. Okay, so I will check if there is a heater on the left side or not, and if there is no heater present, then I will store integer dot max value, because here I'm trying to find the minimum distance for left side and the right side heater. Okay, so if this is the case, it means that left side has no value. Okay, or if we have some heater on my left side of the house, then I will do this to get the distance. Now same goes for here. I will write E dot CL equals to -1. If this is true, it means that there is no heater on my right side of the house. So same thing here, integer dot max value. All right, now we need to take the minimum distance from this. So int minimum equals to max dot min and d1 comma d2. Now we have the minimum distance, and if this minimum distance is more than the answer radius, okay, then what we are going to do, we are going to replace our answer with our minimum radius, right? If min is greater than my answer radius, then answer should be replaced with min. And after we are done, then what we are going to do, we are just going to return our answer radius. Now we just need to write a binary search for the heaters. Why we were doing this? So that we can find floor and seal from the heaters array for a particular house. Okay, now we just copy paste this public static and public static. It should return a pair, and bin search on heaters and house number. Okay, and heaters is a array and houses I is a number. Let's change it to house number. All right, now when we are doing a binary search, what we need is a low value and a high value. It will be heaters dot length -1, and we have now high and low value, but we need to create a pair, so we will create a answer pair. Answer new pair. All right, so this is our pair answer. Now we just need to do binary search, low less than equal to high, and inside this we need to calculate mid first. Low plus high divided by 2, and if mid equals to house number, it means that the heater is in the house. Okay, so what I'm going to do is I'm going to put p dot fl equals to house number, and p dot cl equals to house number, and then just return this p, or let's say we should break this. Okay, else if my mid is less than my house number, it means that my house is here and I have found a heater on my left side. So this is representing the floor. So p dot fl equals mid, and now I should update my low mid plus 1. Now I have found the heater is present here. Now what I'm going to check if there is a heater present beside this, because it's possible that the heater that I have found right now may not be the closest heater to the house. All right, and same here, if the heater is on the right side, we have found a heater on the right side, and this heater might not be the closest heater from the right side to the house. Okay, so p dot cl equals mid now, and high equals mid minus 1. Okay, and after we are done with this, we just going to need to return our answer pair. Okay, I have used p here, so I will change to answer, and here to answer. Okay, I have written a code here. Now I have done some code here and I have made some mistake in this part. Can you figure this out, what I have done? If you haven't figured out it yet, I will suggest you to pause this video and see where I have made a mistake. Okay, so I think you may have found it or you may have not found it, but let me tell you what I made mistake here. So I'm comparing mid with the house number. Okay, is mid should be compared with the house number? Wrong. If you are saying yes, then you are absolutely wrong. We need to, this mid is representing the index of the heater array, not the position of heater. Okay, so instead of this I should write heaters mid, and here too heaters mid, and here I should do heaters mid. We need to store the actual position of what? Heater, so that we can calculate the distance. This mid is representing just the index at which the heater is. Okay, now heaters. All right, now is it right? Think about it. Is it right? Or should I write heaters HN? No. If you said yes for this, then you're wrong. This is house number and this is nothing but houses I. You can see this is also representing the house number, not the index of the house, right? So I think we are done with the code. So let's run it. Okay, public static pair, what it has expected. 8. Okay. Okay, I forgot to put class here. Right. Now let's run it. Semicolon. Okay, let's run again. So it's taking some time. Still some mistake here. Okay, I have written maths. It should be math dot min. Right. Right. It's accepting for a sample test case. Let's submit it. Okay, we got 10 out of 10, which means all test cases are running. Now let's talk about the time complexity here. Okay, so this is my code. All right, this was my pay class, and this is the actual thing that we were doing. So let's see. All right, so we are using a binary search here. So how much time it should take? It should take log n of time, and I'm sorting the heaters array. It's going to take log n time, or let's say it's taking m log n, because the size for the number of heaters are m and the number of houses are n. Okay, so let me correct it. It will be log m log m, and this loop is going to take n time, but we are calling a binary search function here. So this entire thing will take n log m. All right, I have already explained why log m here. Houses array is of size n because there are n number of houses, so n log m. Now whichever is bigger among these two is going to be the time complexity. So a time complexity will be either m log m or n log m, whichever is the higher value here, this or this will be my time complexity. But if you will look here, you will find that I haven't used any extra space, so my space complexity will be constant. All right, so that's it for the code. It was a very simple code. It's just that the word problem sometimes feels very difficult to do. So my suggestion for you is try to visualize that problem into a scenario like I have done here. I built the houses, I built some heaters, and try to find how I can reach to my solution. Okay, so that's it for the code part, and our solution ends here for the heaters problem. So that's all for this video. I'll see you in the next question.